This is Linux In-Laws, a podcast on free Libre open source software, broadcasting from the United Kingdom and Germany.
Welcome to Linux In-Laws, Season 2, Episode 47. Martin, what's on your mind today? Apart from the rolling heat wave, full disclosure, we are recording this in... This is another Time Warp episode. We're recording this in December of 2025.
Why?
Temperature in Germany has just risen to 50 degrees centigrade in comparison to the summer, where it kind of stopped at just about 40, as in short of.
And you haven't even mentioned the flooding here this time.
No, never mind the Vogon's landing, but that's going to take place. Sorry, we can't mention that because we're going to cause a ripple effect, right?
It might come in quite handy, them landings, so we've got somewhere to
Martin,
leave.
You want to be loose on the facts because you will cause a ripple, as in another phenomenon. If you're going to spill the details, as in beans. So, Martin, you can't do this. You know, right? You know why, and so forth.
I do.
Yes, it's called traveling. It's called a time traveling phenomenon. If you travel forwards in time and then you travel back and you spill the beans of what happens in between, you will cause a change.
Well, this is not proven, is it?
It is, actually. Just read up on it.
Well, by some fantasy novelists.
No, by time travelers, Martin, and they do exist, apparently.
Oh, okay.
But this is not a... sorry,
Feel
Martin,
free to
go
send
ahead.
them my way. Yeah. I would like to.
Martin,
I have a few questions for you.
They were on your doorstep last night. Apparently,
Were
you
they?
missed them.
Ah.
Yes. Because apparently...
You don't answer the door to strangers.
No, apparently, again, nobody was there because I reckon you were kind of... I wouldn't say blatantly drunk at the pub, but somewhere close to
No, that's on
stage.
Wednesdays. That's on Wednesdays.
Okay, anyway, they missed you.
Anyway, you can't afford
in more ways than one.
Anymore. It's way too expensive these days.
But this is not not another episode about time traveling, but rather about Martin. What is the subject of tonight?
Well, the actual subject
it's not
is the actual subject is supply chain, but
yes.
we are going to be specific about the software supply chain, really.
Yes, indeed, very much so. So we are not talking about toy assembly and car manufacturing. No, it's just software.
We're not interested in plastics. Yeah, okay.
Exactly.
Indeed.
No, Martin, why is that important?
Why is it important? Because, as we know, a lot of software isn't just written from scratch by, starting from zero code, right? It is a lot of components, libraries, etc., are being reused to create the end result.
So it's not another... go ahead.
Take something like, the text one. What's the name of it again?
The text one?
The text library.
Text library. What do you mean by text library?
Oh, it's frequently used by many software projects to implement full text. Not the name of it now. Anyway, I'll come back to me. But yeah, that's the one example.
You're not referring to LeftPad as part of the NPM
No, it's one
ecosystem.
of the original projects around full text. Lucerne, yes, that's the one.
Lucerne, okay. Links maybe in the show notes if Martin can get back to me on this one. What I wanted to say is actually that so it's not another blatant excuse for the in-laws to do another episode. So there's real meat to the bones. I see.
We are doing an episode.
Yes. We are.
We don't need an excuse to do an episode. We do them all the time.
But you see, the thing is basically software supply chain issues were around before we decided to do an episode on it. Yes.
This is very true.
Very much
yes,
so,
yes. Yeah. No, that's a fair point. Yep.
So essentially the idea is basically to reuse anything under the sun because you don't want to build everything from scratch.
It does help save a lot of time, right? And also, by making use of libraries, we have the whole thing about many communities or community people working on the same thing, etc. So combining forces rather than one company writing it all, one person writing it all himself, and then spending a lot longer on it, making the same mistakes or not, or implementing the same things, right? So that's why we use libraries, etc.
The phrase that Martin is actually looking for is called "we are standing on the shoulder of giants" when it comes down to free Libre open source software components.
Yes, indeed.
But with that approach, there are certain challenges.
Yes, of course.
As there always are.
Well, yes. I mean, okay. So let's pick an example, right? It doesn't matter which one we do, but
name any. Log4j.
Left
hat.
Yeah,
whatever.
Okay. Those are the ones that kind of went wrong, right?
Yes, Martin, indeed, very much so.
Yeah.
Because eventually we will also come to the risks and challenges and whatever, and the issues around this.
We do.
Yes. In about 4 hours, 25 minutes, and 30 seconds, if the script is anything to go by.
A script? What?
Yes, Martin, the script.
Hang on a minute.
Anyway,
Grumpy's
carry on. Martin, the script is actually either on your screen or the printer right in front of you. So just keep reading.
Script? What? Since when are we doing scripted stuff? That's.
Oh, Martin. Another case of memory loss. Okay, but apparently you also didn't get the memo.
I missed that memo.
Not to worry about it.
Free form.
Exactly. Just keep reading, and in case there's nothing
they
to
only
read,
introduced agendas like a week ago.
in case there's nothing to read, just make something up.
Okay.
As we normally do.
Right. What was the question? What are we talking about?
The question was actually why is the supply chain
okay.
important and much more important is actually why there are issues and why there are challenges and why you want to keep an eye on your software supply chain just in case. Yeah.
Well, I mean, the first one is with any software is maintenance, right? How are people maintaining these?
Very much so, yes.
Source libraries and keeping them up to date. I don't know, are they fixing CVEs or whatever, right? So stuff like that. And also just, are they keeping them up to date with latest releases of dependencies themselves, right? They may have dependencies themselves on
as they normally
Linux components or whatever, etc. So
Bitrot.
That's the word.
The word that you're looking for,
yes,
exactly.
Yeah.
Bitrot comes to mind, of course. So you don't want to build your empire on something that is already crumbling.
Mm-hmm. And then, secondly, another point would be if, so you're relying on a library, you don't know the ins and outs of how that's been written, who the people are potentially that are contributing to that. Who knows if someone is putting something malicious in there, right? As we have potentially seen before.
So you want to make sure especially that you vet any component of your tech stack.
Yeah.
Especially if it's not open source, but we're gonna for the time being we're just gonna
then it becomes even harder, right?
Exactly. Yeah. We're gonna just stick to open source components. So
I think that's sensible.
You want to take a look at for example, at GitHub metrics. How many contributors are there? What is the frequency of the commits? How long does it take to resolve an issue and all the rest of it?
Well, how. What's the project's kind of policy or rules around accepting commits, right, as you were saying, so who can supply code to that project and not?
Yes.
Some sufficient guardrails around that.
Contribute license agreements come to mind, but we won't go into this because there's a whole separate issue, a separate episode on this on that issue. Links within the show notes. There is a licensing episode. So in the interest of time, we will find links in the show notes. Martin, by the way, marketing just got back to me and told me that
which marketing? What?
The marketing department that I just hired.
Oh, okay.
When you weren't looking.
Yes, obviously.
And they are still in stealth mode, Martin. So there's little point in firing them because you can't track them down for a reason, I might add.
Can't track them down. Well,
no, Martin, you won't be able to because the HR system already has been rigged accordingly. But not to worry about this. coming back to the original issue, the licensing episode is actually one of the most frequent episodes referred to in other episodes of the podcast. Never mind downloaded episode, because apparently there are quite a few people who can't get to sleep at all, and as reported quite a few times before, are suffering from serious bouts of insomnia. So people, if you can't get to sleep, that's the episode you want to listen to.
Well, and it's obviously cheaper than any medication, and also healthier for them.
And less side effects, exactly. But getting back to the software supply chain, Martin.
See, I should be in marketing. Anyway.
No, Martin, sorry, I'm afraid there are no free headcounts left in that department.
A shame. Yeah. Right, let's go.
Okay.
Yes.
So going back to, say, history topics on the software supply chain, the whole thing started in, I'm tempted to say, in 83, maybe in 98.
Okay.
Martin wasn't around then, I was. No, 83 was actually the birthmark, so to speak, or the point in time when a guy called Richard M. Stallman decided to get cracking on a project called GNU. And 98, of course, as we probably all know, somebody, and in a literal sense now, as in the open source initiative, decided to put pen to paper in terms of what does an open source license really constitute, and what makes software, as in freely available software, really open source and freely and open source software. Okay. As in, what does this FLOSS thing really mean?
Yes, I mean, you could argue that if there wasn't any FLOSS, then you wouldn't have this problem. But then you can easily insert a malicious actor into a software company as well, right? So.
Yes, Martin. By the way, without FLOSS, we would be still living in the Stone Ages.
Stone Ages? What about them? What?
Stone Age, in terms of there wouldn't be that kind of universe of free available software components that you could simply build your stack upon, because at the end of the day, imagine you wanna build your next crypto exchange. I'm just picking a random example here.
Okay.
You're not doing this from the ground up, because web servers will be Nginx, Apache, and some other components. Load balancers will be what's it called? Envoy, Convoy, something? Don't know. Envoy, yes. Thank you. Maybe Nginx and HA proxy. Never mind your operating system. More than likely will be any Linux variant.
Yeah.
And the list goes on. So the idea is basically, if you have a business case at hand, you just want to write the missing parts, as in some parts of the business logic that do not exist yet.
But I mean that's okay. So that's kind of more application level. But then even on the let's say more the back end side, as I mentioned, right? So take Lucerne, right? So if you want to build a full text search engine, you could write from scratch into your whatever database you have, right?
Lucene, of course, being one of the most prominent examples for full text search engines, dating back to 1972. I think.
Well, there's your example, right? It's the whole point of the reuse and the
full disclosure, it was originally written in COBOL. I'm joking. Until somebody decided to re-implement this in Java. The jury is still out on the topic, which is the worst implementation language of the two of them. But sorry, I didn't want to interrupt, Martin. Do go
on. So anyway, you were talking about applications, right? But also, it also extends to more back-end components that, you start, take all the vector databases that come up, right? Okay, fine. So they build a few things from scratch, or they use existing libraries for their HNSW index builds or whatever, things like that.
I mean, just because Redis probably being the most prominent example, right? Because the core engine is still the same, dating back to 2009 or 2010, 2009 actually. But the additional functionality was just tagged on as a module.
Yeah, and as part of those modules, they will be using various other libraries that give them the functionality they need rather than writing it from scratch as well.
As you would.
Yeah. So anyway, so those are various cases for knowing your supply chain, right? It's as a organization, when you're building something, you want to know where your software comes from. Usually okay. So with open source, that's you don't have any. Okay, a lot of organizations go for vendor-supported open source, right? Because then they have someone they can hold accountable. Let's put it that way.
Somebody they can shoot if things go wrong.
Yeah. I was going with the more accepted term, but yeah.
Martin has just concluded reading the textbook on diplomacy. Martin, do go on. Fair enough. Fair points to you.
Yeah.
Full marks to you. Okay, go on.
Yeah. There we go. So yeah. So it's at various levels, right? It's not just it's a component level. It's at levels above. It's at the organizational level when you're trying to implement something or build something on top of it. There are always things that you will trying to make use of, whether it's a library or you mentioned Redis or whatever, any other piece of software. Knowing the supply chain, if you're going to use those, is important.
I mean, that goes right down to the operating system level, right? I mean, if you're picking an obscure Linux distribution that is no longer supported come 5 years' time, you may have an issue. That's probably one of the reasons why many people are sticking to, as Martin already pointed out, subscription-supported alternatives like the Red Hats of the world, the Ubuntus of the world, where you simply pay money and some company basically does the maintenance for you. Because as we all know, not that many people use Slackware in production these days. I'm just saying.
Yeah. I mean, it also comes with a benefit, right, for the fact that those open source projects do end up being maintained and so on. And the people that work on them actually get food on the table. They get paid per someone.
Indeed.
Yep.
It's probably now time to go into some more intricate details, like, for example, software bills of material, as in SBOMs. And for the people who are now struggling with the term, if you have programmed Java, first of all, shame on you. I'm joking. Good luck. But you will have come across a repository called Maven. And with any ordinary Java project, and Java is just a kind of stand-in term for Kotlin and some other languages running on the JVM like Scala and so forth, you do have these BOM files, which are an example for an SBOM. Same goes for I think in Python it's called Project Polytomo these days. It used to be requirements.txt.
Yeah.
In Rust it's called cargo.toml. Exactly. So and the list goes on, by the way. And these SBOMs do contain the dependencies of your project. Needless to say,
down to the version as well.
But of course, if you choose to specify the version, exactly.
Well, yes.
Sometimes you can, or it does make sense to specify a specific version, but sometimes you just want to have the latest or the stable, if not both. And then the build system tells you, sorry, you want to either have stable or latest, but not both. Yeah, package build comes to mind, which is an SBOM for Arch. And a little bit more, but we won't go into the details. Yeah, I mean, there has been enough suffering, I reckon, along that way. So we're going to leave it at that. Okay, jokes aside, no, SBOMs are pretty important because the SBOMs in turn are resolved by the build system, as in the system basically that takes a look at your code base and tries to make sense of it. Not only the code that you have written, but also the dependency in this code. And hence this SBOM and any build system, what it solved, will of course resolve the requirements recursively in terms of it will take a look at the requirements. And of course, these requirements also have requirements. If you build any Rust application beyond a certain size, as in about 10 lines of code, you will notice that the build times increase exponentially. And Hello World pulls down about 20,785 requirements. I'm joking. The actual number is actually 10 less, but you get my drift, no jokes aside. The thing is that there are language ecosystems, and Rust is probably the best example here. And I'm not trying to I'm not trying to diss Rust here, because as we all know, Linux In-Laws actually is a Rust marketing podcast. Rebecca, if you're listening, the email address is
sponsor at. Yeah.
No, jokes aside. No, I mean, it really depends on language. I mean, Golang is probably another good example for this, because Golang, as probably some people know, tends to build statically bound libraries similar to Rust. And so they pull down all the requirements, or the build system pulls down all the requirements required, including the requirements of the requirements, and build times tend to get longer. So that's another kind of example of why SBOMs are important.
Well, I mean, an SBOM is not going to, it's just going to tell you what it uses, right? Not actually do anything else to verify anything about those dependencies.
This is where the magic comes into play. Exactly. Yes.
Do tell.
Because if you want to pull down, if you are putting down these requirements, you want to make sure that they come from a vetted source. GitHub probably being the most prominent example here. But even GitHub can be compromised, as we all know. The XZ attack, dating back about what? Back to December of last year? Was it this year? I can't even remember.
Well, it can't be December this year.
No, I mean...
No, last year, yeah. 2024.
Exactly, 2024, exactly. So... Yeah. And yes, Canonical actually halted the Ubuntu release cycle, as in stopped or paused the Ubuntu release cycle to make sure that any package dependency they pull down is free of this malicious vector containing the XZ library. Details, of course, within the show notes. Suffice it to say, it took the more than likely state-sponsored actor about a couple of years, if not 2, to acquire the trust of the original maintainer.
Yeah.
And hence he or she or they, it's probably more like they were able to sneak in the GitHub repository and insert some malicious code.
Yeah, but they weren't actually sneaking in, right? Because at that point they were a contributor, so they legitimately got to that stage. It's just that nobody knew that they were malicious.
Well, true and not true, because they had malicious intent.
Yes, but they didn't. Nobody knew that until afterwards, right?
Correct.
Not at the point that they let him in as a contributor.
Correct.
At this point, yeah.
But very important, GitHub does not validate /vet source code. Some other systems do, but GitHub doesn't. Hence the kind of wide open entry to just give it a go. Let's put it this way. I mean, at the end of the day, you want to make sure that you have a minimal attack surface of your build. And by build, I mean, essentially, you pull out the libraries, you have your code base, you then build.
Are there actually analysis tools for the SBOMs in terms of to check those dependencies for more than just it's a dependency. It comes from a source, but
many.
Okay, do tell.
The OpenSSF retains a whole slew of repositories.
The OpenSSF. You should probably tell people what that is.
This is the Open Software Security Foundation, a subsidiary of the Linux Foundation. Blatant teaser, there will be an episode on the OpenSSF. I won't give away too much.
Okay.
In the near future, let's put it this way.
Yeah.
No, jokes aside. Links will in the show notes, of course. But the OpenSSF does have a pretty comprehensive ecosystem of tools just exactly addressing this issue. It ranges from a Git repository analysis tool by the name of GitHub, right up to how you actually protect your GitHub repository and how to analyze things that you pull down from some other source. It goes right from package analysis to how you consume open source repositories. So that goes right from, okay, I have this dependency as part of my SBOM, but what am I really putting down, and is it safe to do so?
The OpenSSF has this framework, right, to let's say where people can use a framework to enhance the security of those pipelines, right?
Martin is referring to the supply chain integrity working group, I suppose.
Well, they have a framework called SALSA or something, which is
this is one of about 25,748. Yes.
Yeah, well, this is the one that OpenSSF is stewarding. But
there's just more than one. As I said, it goes right from GitHub over to GUACMinder, OpenBOW, OSB, PS Baseline, and SALSA as an SLSA is just one of the frameworks in this ecosystem. Of course, links will be in the show notes. But Martin, how do you get to an SBOM? Say, exactly.
One.
Say you have written this new crypto.
How do you type it in yourself?
You see, imagine yourself, Martin, sitting down on a Friday night, having this wonderful idea of why Kraken, Bitcoin DE, and all of these other what's called not Bitwarden, but BitX or something, why all these other crypto exchanges are simply failing.
Okay.
So you write your own crypto exchange.
Okay.
Because you can and because you do.
Fair enough.
So come Sunday night, the code base is ready. It's ready to roll. Some of your closest friends do have the URL between the Sunday lunchtime and Sunday evening 6 p.m. because they have been exposed to the alpha version of the code base. They're already trillionaires, so it does work. Proven point. But now you want to open this to the broader audience, as in monetize the whole thing come Monday, so you can retire lunchtime Tuesday.
Okay.
Make sense so far? Excellent. Okay. But in the rush of getting the code base together, you have really forgotten one important aspect. The SBOM.
Yeah.
Exactly. So you have because much of the stack is written Python, you have your project.toml in place. Some of the time-sensitive components are written in Rust that you got from these trustworthy Russians, I suppose. But also they forgot to put together a corresponding relevant toml, as in cargo.toml. So what do you do? I mean, you have these about 276,870.5 lines of code comprised of JavaScript for the front end, some JavaScript for the back end, soon to be deprecated, by the way. Never mind Rust, Python, and some other components.
I think the answer to your question is use a SBOM generation tool. No?
Yes, Martin, very good. So what do? You use one of these tools, exactly. So thankfully enough, the Russians supplied Docker files.
Yes.
So that
not that we have anything against Russians, by the way.
No.
Other countries are available.
No, exactly. And we
Like
don't
China.
have, and we don't have anything about Docker being container runtime. Just let me be crystal clear.
Yeah, Podman is an option.
Fair enough. No, Podman is available. Run C and all the rest of them. So this is just an example, people. Right? So just hear us out. Okay, but the rest of the code base is blank in terms of you have...
Doesn't sound much like a code base if there's no lines.
I mean, blank in terms of, for example, the Python code files do contain imports, but that's as far as it goes.
Uh-huh.
Because as we all know, Python is not bound to a particular build system because it's not a compiler-based language. And if you're lucky, you do have requirements or text. But now Martin, in the rush of things, has completely forgotten about this requirement or text. And never mind Project.toml, which is a new SBOM format for Python, and has simply coded away just to keep the friends happy and to monetize the whole thing come Tuesday or starting Monday morning first thing. So the social media campaigns are already up and running. And
wow.
yes, exactly. So you just want to put this into a cloud environment in a controlled CI/CD fashion, as in continuous integration, continuous deployment, because come Monday, the bots are still writing some of the missing pieces of the code. As you would, as in bots now meaning LLMs, as in large language models. The pieces of software that you normally use these days to write other people's code. Anyway, it doesn't matter. But even the LLMs are far from complete, so they also forgot about to include the bombs, as in the SBOMs.
Okay.
So what do? You use SBOM generation tools. Links put in the show notes. That's the end of the episode. Thanks for listening. No, jokes aside, there are quite a few of them. Swift by Anchor is probably... Okay, we should probably set the scene of what's really an SBOM really is, apart from the usual suspects, like Cargo.toml and requirements or text and all the rest of them, because they...
it's just a list of components, really. That's exactly what a bit of material is. It's just in for software. So,
but this is... They do have one important trait. They are all language specific. So Cargo.toml relates to Rust.
Yep.
Project.toml relates to Python. And if you're lucky, you're using CMake, Meson, and Amazon and Ninja for some modern build systems, which are language agnostic. But they, in turn, expect a CMake.txt file that does contain your bill of materials. So, tools to the rescue.
CMake files are fun. Yeah, anyway, keep going.
Are they now, Martin? Excellent. Yes. For those people who do not know what Martin is talking about, there was AutoTools and AutoConfig, and then time went on for about 60 years, and some bright spark had the idea of, okay, this can be done better. 60 years, of course, is an approximation. It may have been 30.
Or 59, yeah.
Links maybe in the show notes. Anyway, so the idea is essentially that you have two standards called SPDX, if I'm not completely mistaken, and Cyclone DX.
Okay. Which,
of course, are de facto standards in the continuous integration and continuous deployment ecosystem. SPDX, man, why does that ring a bell?
That's a good question. I don't know.
Think licenses.
It does ring a bell.
Think licenses.
Why?
Because that's essentially where SPDX comes from.
Is that where it comes from? Okay.
Yes.
Fair enough.
You throw an open source code base at it, and it tells you exactly which components are licensed under what licenses.
Okay. Cool.
In terms of what parts of code base adhere to GPL and friends, what are licensed under more permissible license like MIT BSDs and Apache and so forth. But SPDX has gone full throttle in terms of not just identifying licenses, but also generating, and links, of course, in the show notes, generating SBOMs. And another de facto open source standard is Cyclone DX, which comes from a company called Cyclone DX. And they, if memory serves correct, actually come more from the security angle, as in what attack surface does your code base and its requirements actually build in terms of exhibit when you build the executable. we should probably explain what the attack surface is for the people who just turned into the podcast and do not know what we're talking about.
We did do an episode on.
Yes, but Martin,
stuff like that.
for the people who are listening to this podcast for the first time around.
Go ahead.
You were doing the talking for a change.
No,
Shut up for a minute.
This is your favorite topic, so I wouldn't want to interrupt it.
Okay.
Yeah.
An attack surface is basically...
Well, actually, probably your second favorite topic after licensing, but yeah, carry on. Oh no, there's Rust as well. Damn, sorry. Third one.
But Martin, keep on talking, and I can stop for a minute. Get another beer or something. Okay. An attack surface is essentially the barn door, which may be wide open in terms of how to get into code base, in terms of how you can attack something that is running on a computer. Attack surfaces go back to 1378, when some...
Oh, no, probably way before that.
Maybe. Yeah, I don't know. I mean, 1378, it was actually... Yeah. I mean, no, Martin. That was actually the first time when a calculator as an abacus was put into production.
Yes, but it's not limited to any calculation machine, is it really? Attack surfaces. If you live in the Stone Age and you have a hut, then the door is your attack surface.
No, Martin, this is called social engineering, which is only a part of the attack surface. But I'm now talking about the attack surface of a piece of software.
Okay. Anyway,
which is different from social engineering.
Is it really?
Yes. If you want to... People, if you want to come back to the subject of attack surfaces, simply fast forward to 2 hours 45 minutes when I have explained the concept of social engineering to Martin in depth.
I think we did that in the other episode.
Jokes aside,
actually, you could probably do that in one sentence anyway. But yeah, keep going.
An attack surface is essentially now confined to a piece of software. Is actually how you break into that piece of software and how you can turn it upside down. Without getting too technical, the whole notion of IT security in terms of software IT security centers on this term. Because if you have such an attack surface, you pretty know what the game is.
It does help, yeah. Okay.
Now that we have established an attack surface, why is that important in an SBOM context? Any thoughts, Martin?
Well, every dependency in your SBOM is an attack.
Martin, go back about 55 years when you were still script kiddie trying to break out into other computer systems, as in other people's systems. What did you do?
Yes. I wasn't really that far advanced. I don't think I was coding at 1 or 2 or 0 even. But yes.
People in the audience, this is also known as a lame joke. But anyway, Martin, do continue.
What was the question?
Go back to your younger days when you were still script kiddie. What did you do?
Well, it depends. What's the question?
The question was basically, how did you try to break into other people's computers?
You just open the door and take a hammer. Yeah, that's always a good idea. A screwdriver is probably more efficient, to be honest.
Yeah, but Martin, imagine that you're trying to break into a computer that is about 1,000 miles away in a secure data center. All you have is actually a remote access.
Back in those days, we just had modems and it was way too slow, so there's no point bothering.
You didn't bother, okay? Okay. Fast forward 2 years. Martin is now in the possession of a decent internet connection.
2 years, wow, that's some development, yeah. Which planet was this on?
Yes. No, Earth, Martin, all those years ago. Okay. And now he's trying to do some serious damage, but failing. Why?
Why don't you tell the audience?
Because the people were smart enough to keep the attack surface to a minimum.
Well, I mean, that's really not a very good argument, is it? Because, yes, okay. No, if you minimize the number, if you minimize the number of or the size of the attack surface, fine, you've made it smaller, but it doesn't mean there isn't one.
The smaller the attack surface,
you're only limiting the access, right? That's all you're doing.
The smaller the attack surface is, the harder it will be.
What does that got to do with the supply chain, anyway?
We're going back to that in a minute.
Are we?
The smaller the attack surface is, yes, we are, Martin. The smaller the attack surface is for the fifth time now, the harder it will be to break into your system. coming back to the SBOM and supply chain issue.
It depends how big the door is, right?
Anyway, Martin, you nailed it. That's precisely it.
But that's what you're saying. It depends how big a door is. But if there's like 5 doors instead of, then that's worse than having one big door, right?
So you want to vet your software
you just bring
components.
A few midgets that fit through the small doors. Anyway.
No, Martin, exactly.
Small people. Yes.
Yes, okay. I mean, just before you try to sue Linux in-laws, we don't have any money. Martin made sure of this.
Vertically challenged people. Yes, carry on.
No,
that wasn't me. That was you hiring marketing people all the time. Anyway,
Martin blew it all on. I'm going to delete it. Listen to some previous episodes if you want to know what Martin blew the hard-earned venture capital on. Anyway, it doesn't matter. Going back to the barn door.
Barn door, yes.
Exactly. So, no, jokes aside, the thing is that you want to make sure that you know what the attack surface is of your components that are part of your software ecosystem, hence the SBOM. Because if the SBOM is correct, you pretty much have a good idea of what components you're putting down, what the vetting status is, where they come from, what the bit rot factor is, and all the rest of it. For example, I'm using components that have a lot of open CVEs as in known vulnerabilities on them.
Yeah, what about the unknown ones, though?
Exactly, Martin. What about the 0 days?
Yes, indeed.
So, Martin, there's a startup idea. Actually, maybe some companies are already in the game of doing this. I mean, why don't you write a software that kind of goes to the darknet, pulls down these 0 days, and combine that with an SBOM vetting system?
Is that too late by then?
I mean, that beats the crypto exchange idea by miles. Because you're not talking about Tuesday, but you're talking about Monday morning.
Once the 0 days out there, it's too late.
You see, not all script kiddies access the darknet.
Point is, you were trying to avoid 0 days, right?
Yes, but you see, Martin, you can't. That's the point. But before we go further, we should probably explain what a 0 day is.
Well, kind of implied by the name, but yes.
So, Martin, what's the 0 day?
It's a vulnerability that's 0 days old, as in it hasn't been seen before.
No, it can be actually 1 or 2 days old too. Never mind a week or two.
Okay, well, as long as it hasn't been seen before. Yeah.
No, actually, it has been seen before because otherwise it wouldn't be a 0 day because somebody managed to exploit it. But the important trait is that there is no known cure for it. In terms of there's no known patch released or not for this vulnerability.
Yes, and
that's the main trait of 0 day.
Yes, well, fair enough. Yeah, okay.
And so to continue this business case, I mean, if you manage to pull down enough 0 days for any given SBOM or whatever, you're off to the races.
Well, yeah, but I mean, they don't tend to stay around for long, right? The 0 days. So,
it depends on where you see them first. I mean, if it's some obscure corner of the darknet that nobody really visits, fair enough. But as soon as they become a known CVE, as a common vulnerability enumeration, because that's exactly what CVE stands for, chances are that somebody will take note and that somebody will take action more or less immediately. So the 0 day will be gone, and before you know it, there will be a patch.
Yeah, no, I mean, that's a good point, right? It's, they can remain unknown for some time. Okay.
Anything that we didn't talk about before we wrap this up? I mean, we can go on for hours on this one.
Yeah, we kind of, we're missing another bunch of set of tools, right? So we talked about SBOM generators, but there's also software composition and analysis tools, right?
The likes of SonarQube and so forth, as in static and code analysis.
Yeah, SonarQube, that kind of stuff. Yeah,
or JFrog, to mention a proprietary example. Yes.
So, what are these?
Static code analysis essentially analyze your code before they go into build.
Okay, I'm just waiting for the rest. It's normally not like you. So.
Why do I have to do all the talking, Martin? I'm just wondering,
This is
like,
one of your favorite topics.
is it? As
It
in the software supply chain, I thought I was just the security guy.
Well, surely this is part of this whole ecosystem of security stuff.
Martin is just enjoying listening to my rambling so much, I suppose. That took about 1/2 a second too long, Mr. Visser, but don't worry about it. Okay, no jokes aside. But I mean, the whole thing boils really down to continuous integration, continuous deployment issues, because the software supply chain is just a part of your CI/CD pipeline. Goes without saying. And along that CI/CD pipeline, you want to use any software quality assurance tool chain that comes to mind, given your business or use case. And static code analysis would be just one example. You want to use kind of automated software quality assurance things like fuzzy testers and all the rest of them to make sure that your build that enters production deployment is actually rock solid and will survive just more than a smoke test. As when you start up the binary and it doesn't crash immediately. It generates 1 or 2 log messages. Exactly. Before it continues to work on the business case. In the ideal case, it will do so for a second to maybe an hour or something, maybe even a couple of years before it eventually crashes or whatever. No, jokes aside. Continuous integration, continuous deployment is another whole mini-series of about 2,700 episodes, so stay tuned. Exactly. But, and SBOM is, or the supply chain is just an important part of the CI/CD pipeline.
Yes.
I mean, we did already an episode on quality assurance, if I'm completely mistaken, right? QA comes to mind.
Yeah.
Yes. But...
Yeah. But actually on this, thinking about this, I went to one of the Linux Foundation conferences a few weeks ago, and
Martin,
you presumably heard of the Cyber Resiliency Act.
Yes.
But this is, I mean, the OpenSSF is doing a lot of work in this area, obviously, but putting this into an act is obviously something that comes in 2028 or something, I think.
And requires a lot of bribing, if I'm completely mistaken.
Probably.
But OpenSSF, fair play to you. Well done.
Yeah, no, they're certainly doing their bit to raise awareness, right?
Absolutely.
So, for sure.
Yeah. And I think I mentioned that before, but we will have them on the show, right?
If they turn up, yes. Indeed.
Yes. Oh, I'm pretty sure they will.
Okay.
Because Martin has managed to secure some of that bribe money, and so in turn has bribed the OpenSSF to attend. Exactly.
Yes. Okay. So where do you think this is going?
World domination. Similar to the
software supply chain is
exactly.
Okay, fair enough.
Yes, similar to the Linux in-laws. Unfortunately, the supply chain is way ahead of us. While we are still thriving for this, the software supply chain has managed actually to dominate the world. Because if you're taking a look at any serious CI/CD pipeline, software supply chain issues are at the very top of this list, as in how you secure your software supply chain, how you harden your builds and all the rest of them. So this is pretty important. And I'm not talking about a marketing website that if that marketing website goes down, there will be no immediate impact. I'm talking about the likes of Amazon.com or Google.com or something else that generate millions per second in terms of revenue.
I don't know how much money.
Or Martin's crypto exchange that will go live come Monday.
Unlikely, but yes.
Stay tuned. Watch linuxinlaws.eu. You may see a URL pointing to this.
We would have to update the website, though. But yeah. We have people for that now.
No, we don't, Martin, but we do
we have volunteers, yeah.
No, Martin, we do have a software supply chain for this.
Excellent, we do. Yes, we do.
Because if you take a look at our workflow, you will notice that this is actually an SBOM in the making. Not in the making, but in the works.
Yeah, indeed.
Because we record an episode, the artificial intelligent characters, affectionately known as Chris and Martin, do record an episode, then this is being dropped into a workflow that does maybe light editing, depending on if we have guests or not, and then does all the magic behind the scenes in terms of updating the website, uploading the media files, updating the metadata, social, and all the rest of it. Exactly.
Did you check Nextcloud's SBOM anyway?
Nextcloud SBOM?
Nextcloud, yeah.
Not SBOM. Why would I?
Well, because we're using it, so...
Yeah, but I mean, I haven't updated that Nextcloud instance for about 20 years, so...
okay. This is what not to do, kids. Yeah.
No, links won't be in the show notes.
Yeah.
Anything else we should add, Martin, before we have to dash?
Indeed.
Or come to the boxes, for want of a better expression?
Okay.
So, Martin, what's your box?
My box is something called Valky Search.
Oh no, another Valky module.
Well, the reason, not for any other reason that, it is quite a cleverly built and architected piece of software.
So how does Valky Search differ from Redis Search?
Well, it was, first of all, written from scratch.
In what language?
C++.
Why not Rust?
Well, I didn't write it, so don't ask me.
So who wrote
anyway,
it?
There's nothing wrong with C++.
Oh, Martin, there's a million things wrong with C++.
Well, there's also many things wrong with Rust. But from a pure performance point of view, there is no benefit to doing things in Rust.
Martin, who made that call about the implementation language?
Probably the people who wrote it.
Did you have a say in the matter, I wonder?
No.
You didn't? Okay.
No.
So why was C++ chosen in favor of Rust or some other cool language?
Because that's what the people have been developing in for 10 years or 20 years, whatever. I don't know. I don't...
So it's called bias. Okay, fair enough. Wouldn't be the first time happening. Okay.
Well, there was a reason why C++ came out in the first place, right? I think we probably covered this in a previous episode, but yes.
Did it? I mean, if you take a look at the...
No, we had that forum with the three programming guys. What was it? C++. What was that episode?
That was the language panel about 20 years ago.
Yeah.
Episode... Season 1, episode 52, I think. But as I said, it's about 20 years ago. Check out the back catalog. It was Python, Rust, and C++, if I recall correctly. I might be wrong, but C++ and Python certainly were in it.
Yeah.
But if you take a look at the GOB, never mind Stack Overflow index as of late, as in within the last half year, you will notice, Martin, that Rust has clearly taken the upper position that in the popularity list. So
we all know what these popularity lists are about.
Do we know, Martin? As in, Mr. Vista rigged the system so that C++ tried to make it, but somebody stepped in and said, "No, look, we noticed you're rigging the system."
These indexes, or whatever they're called, they're purely a reflection of what people want to have on their CV.
But you see, Martin, funny enough, GOB and Stack Overflow is not LinkedIn. So
it isn't. But you ask any developer and you say, "Oh, which language would you like to use?" Then they will say the right answer for what they think is the best for that job.
You see, Martin, in that case, JavaScript would be topping that list, but it's not. If you get my drift.
I don't think so. No.
As a matter of fact, JavaScript is scoring quite low on these lists. So much for that argument.
Anyway,
going back to much safer grounds. Exactly. My POX is actually a movie called Thunderbolts. Won't give away too much. It's an installment of another Marvel's story. So essentially, it's about 7 outlaws being wronged. I won't give away too much, but if you have about 2 hours to kill, and if you're into that sort of ecosystem, I really enjoyed watching it. It's about the darker side of the Marvel's ecosystem. You don't want to miss this. And with that, Martin, we've come to the end of another glorious episode, I think.
Indeed. Well, it's only part 1 of 10.
Yes, Martin will do the remaining 9 episodes, so stay tuned. And with that, thank you for listening.
This is the Linux In-Laws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
We hope you like this feature presentation. If so, please spread the word. If not, please let us know. Feedback at linuxinlaws.eu.